Okay, so we're looking at number 12 using our slope formula. I labeled my x1, y1, x2, y2, and plugged them into the formula here. And now we just have to simplify. 6 minus 1 is 5. Negative 8 minus 4, we get a negative 12. Okay. And there's our slope. Now we do want to check, once you find your slope, can we simplify it? We don't want to turn it into a decimal. So we either want it to be a fraction or a whole number. Decimals, they're not as useful when we're talking about slope, okay? So we're going to take line 2 now, and I'm going to do the same thing. I'm going to write it in red. I'm going to calculate the slope, and then we're going to compare them to decide which one is steeper, okay? So line 2 is here. I have my x1, y1, x2, y2. I'm going to take my coordinates and plug them into the formula. Remembering the y's go on top, the x's are on bottom. I have my y2, which is negative 8, minus my y1, divided by my x2, minus my x1. Okay. So simplifying on the top, negative 8 minus 4, we get a negative 12. Negative 1 minus a negative 2. When we have this double negative, minus a negative 2 is like adding. So negative 1 plus 2, we're going to get a positive 1. And we can simplify this. We could say negative 12 divided by 1 is a negative 12. So I'm going to pause there for a second. This is an example for your notes. So please write down everything I'm showing you. Then you'll have something to look at later. Okay. So you can work ahead if you already know how to do it. Okay, so to finish this question, now we have to compare these two slopes. We have two numbers here. Does anyone have a thought about how we can decide which one is steeper? Or even an observation? Okay, if you need a calculator, you can grab one from the front there. If you use a calculator, I'm going to put out some wipes. I'll just ask you to sanitize it at the end of class when you put it back. Okay. So in the back here, and then we'll go to the corner. What do you see?
I see the line is more steeper because it goes practically straight down.
Okay. So it goes practically straight down, saying this one is steeper. What do you see? Same thing? Okay. Could either of you describe, using rise over run, how does this line change? Okay, good. That's the main way we can compare it. How is this changing? It goes down 12 over 1. This one's also negative, so we could say it goes down 5 and over 12. So line 2 is definitely changing at a much higher rate. All right. So second example we're going to look at today. Let's go ahead and turn over to number 15. I'm going to do one of the word problems. Okay. So, adding things that we've talked about so far yesterday and today, we're talking about slope intercept form, where we identified which parts equal our slope, which part equals our y-intercept, and then we have this key idea of rise over run. So we're going to put all these things together to try and answer a question about the Leaning Tower of Pisa. Famous tower in Italy, often referred to jokingly as the Leaning Tower of Pisa. Probably seen it in commercials or cartoons a lot. They call it the Leaning Tower of Pisa because it's actually leaning, something like that. And it has to do with the ground. Like maybe the ground is too wet or soggy or moist, so the foundation is sinking and the tower is slowly tipping over. This question says the Leaning Tower of Pisa is about 55.9 meters above the ground. As of 1997, its top was leaning about 5.2 meters off center. Well, they're saying that if this is the center of the tower, the top is tipped over 5.2 meters. Approximate the slope of the tower. Okay? So I highly recommend drawing a picture when you're working with word problems. If here's our tower, put two dots, the center at the bottom and the center at the top. All right. Now they're only asking us to find one thing. They want us to approximate the slope of the tower. So I'm going to use the information they gave us. They're saying the top of the tower, right here, this distance is 55.9 meters from the ground to the top of the tower. They're giving us one other piece of information. They're saying the top has leaned over, so this distance, I'll put in red, is 5.2 meters. They want to know, what is the slope? What is the slope? So based off of what they're telling us and what we know about slope-intercept, we can use this idea of rise over run to calculate the slope from the center of the bottom to the center of the top. Can anyone tell me, what is the rise? What is the change up or down from the center of the bottom to the center of the top? I'd love to hear from someone I haven't heard from today. What is the rise? If we go from here to here, what is the rise? Okay, I saw a couple hands go up and back. What do you think, Noah? 55.9. How tall is the tower? Well, it's 0 at the ground. If we go up, 55.9. Now, the unique thing about this tower is it's tipping over. How far over did it get tipped over? What's our run? Oh, I heard a murmur. 5.2 meters. It's right here. 5.2 meters. So we can approximate the slope. We could say it's 55.9 over 5.2. Let's see what that works out with a calculator. We could say it's a decimal, and I don't really like doing decimals with slopes. I'd say something like that. Or you could say it's 10.75 over 1. Either of those answers would be okay. So for every meter you go up, it goes over 10.75 meters. No, sorry, I said that backwards. Every 10.75 meters, the rise, it goes over 1 meter. Question?
You also use a squared plus b squared equals b squared.
That wouldn't tell us the slope. That would tell you the distance. That would tell you this length here.
Why?
Yeah. I did. Okay, time check is 9:40. I wanted to do one more example. So far, we've done an example of every type through 16. If we turn the page, I'm going to do number 4. This is my last example of the day. Okay. All right, here we go. Number 4. So identify the x and the y intercept, then graph the equation. The only reason I wanted to touch on this, we've talked about the y-intercept, but I just wanted to redefine them for you. I guarantee everyone in here has learned about x and y-intercepts and used them before. We just want to remember a couple of key features. So looking at number 4, the x-intercept, one thing that is always true about the x-intercept, y equals 0. We can put this word when y equals 0. If we're talking about an x-intercept, y has to be 0. It's always going to be on the x-axis, but a very key important piece of information, y equals 0, okay? And the converse is true. For the y-intercept, well, that's when x equals 0. Okay, so I'm going to pause for a moment. This is our one note for this group of problems. With this information, we can answer all these questions. Okay, because what we're going to see, this is the second half of our assignment. We're going to start seeing some equations that are not in y equals mx plus b. We're going to learn about how we can change them. Y equals mx plus b is oftentimes the easiest way to graph straight lines. But we're also going to learn to work with them when they're not in slope-intercept form. Technically, this one's called standard form, but we don't need to worry about the name as much at this moment. What we're going to do is we're going to learn how to graph it based off the intercepts. And to find the intercepts when it's not in y equals mx plus b, we just have to substitute one thing that we know. For example, question number 4, if I want to find the x-intercept, y has to be 0. So to find the x-intercept, I'm going to plug a 0 in for y. I'm going to do my work up here. I think you all will have a little more room. For the x-intercept, x plus 2 times 0 equals 8. Okay. And this key part of the definition lets us find this point. So I know the x-intercept, y has to be 0, and 2 times 0 is 0. So if x plus 0 equals 8, well, that means that x has to equal 8 as well, right? And we just found our x-intercept. X is 8, and y is 0, right there. Okay. And we can do the same thing to find the y-intercept, except we're replacing the other variable. Looking for the y-intercept, x is 0, so we take a 0 and plug it in for x instead. I have to squeeze my work in. I'll do it down here. So 0 plus 2y equals 8. We can simplify. That means that 2y equals 8. And if 2y equals 8, we can divide both sides by 2 and tells us that y equals 4. I can find my y-intercept, 2, 4. And using those 2 points, we can finish our line there. Tomorrow, and we're going to have the last, see how much time I feel like 15 minutes to work on it today. All right, so that's my last example and my last note. Let's do a time check here. Our class is over at 10:04. I'd like everyone to work until 10:01. That means we have 15 minutes, okay? So your job right now, you have this time to work on the assignment. This is due tomorrow. You can quietly work with a neighbor. I can answer questions. All right.